I try a quick GeoGebra build with no preparation live to see how it goes. There's a problem being discussed on Twitter with Colleen Young and Douglas Butler. Douglas had made an interactive file and autograph, I think. They were talking about whether you could do it on other packages. Or no, they weren't. I was thinking that. And I just want to try and build it in GeoGebra to see whether it's easy or not. The question is about a point P lying on that curve. Well, they say it's a curve. I'm pretty sure it's a circle. Find the greatest and least possible values of length OP, where O is the origin. And the job seemed to be create a visualization of it. So we're just going to start from scratch and see whether we can do it quickly. I'm running GeoGebra Classic 5. This would work just as well in the online version Classic, or even I think in the graphing calculator. I just prefer the offline version, but let's have a look. So I'm going to plot the curve was x squared plus y. You can use Alt-2 to get a square if you want it. Let's pop back to the question. Minus 6x plus 8y. Start again, x squared plus y squared minus 6x plus 8y equals 24. Lo and behold, it is a circle. It is a circle. It's called equation 1. We could call it anything we like. Curve 1, or whatever. And let's make the point at the origin. So O equals... I'm doing this by typing. I almost always prefer typing my commands in. Other people have different preferences. You could just click on the origin with the point tool to get O. That's fine. O is there. But at least typing in, I get to choose what to name it. Otherwise, I have to go and rename it, like what happened with the curve. Let's make a point P. I could do this by doing point command, and you can have a point in a region or a point on an object. Actually, maybe I'll do this one with a click. Click the point tool. Cursor changes there. And that's on there. It's called it A. Let's rename it. Difference with using the mouse. Call it P like in the question. Actually, once it's on there, right click on it and animate it, and this P is now moving around, and that's the dynamic feature that any dynamic geometry is going to help understanding this question, that P moves on this curve. We want the distance O to P. I could just make a segment O to P. Yeah, let's make the segment. I could use the segment tool. Click on O and click on P. I could do that on the screen as well if I wanted to, but I think I still prefer typing these commands. Once you know they exist, you can start typing them and then they'll pop up as an autocomplete. And actually, I just want to plot how that distance, which is labeled as F, changes with the x coordinate of the point P. So I'll just define a coordinate, which is the x coordinate of P. X of P is the command to get the x coordinate. And the y coordinate I want to be F. That's the distance of the segment there I named. So let's just call it F. Hit return. And I think there he is. It's made a new point that is tracking with it. So if I zoom out, I can see what's going on. Whoops, didn't want to build that segment. Let's keep the animation going. Right click, animate. Pressing escape just jumps back to the move tool, so you can always just drag around. And what I really want is to see the path, so I can trace A. Let's just watch that complete. Lovely shape there. This is chasing the locus of the point with x coordinate the same as P and y coordinate the same as the distance from O to P. And you can see when this curve is at the highest and lowest points for the maximum minimum distance. I'm actually kind of not worrying about the question. The point is to create the visualization tool. Actually, this is the trace, so as soon as I move around it disappears. It's a very ephemeral thing, the trace. It comes and goes very easily. You can make it more permanent with a locus command that's buried in this one. Locus, it needs the point you want to make the locus and the point that controls it. So that's the point I want to make the locus and the point that controls it, which is P. And you will see that even when I now move around, there is a line which is left here. And actually that would change if I moved the points around. So let's just stop the animation a bit. Moving P around doesn't change it, but if I moved O around, you can see the actual locus changes with it, whereas the trace doesn't. So this is fully dynamic. Once you've built a locus, it should update. So it's really easy to build, and end of the experiment, I've built the dynamic visualization. I haven't solved the question, but I've got a really nice file which maybe would help a discussion about it.